Good morning. The symposium will start at 9:15. Tranquilamente, sí.
Mir signal.
Good morning, everyone. It's my pleasure and an honor to be the chair of this morning session up until the lunch. Without overdue introductions, I would like to inform you that the first presentation will be done by Renate Nanchev. She did it with Elske Ammenwerth. They come from Austria. The title of their topic is E-Moderating, a modern framework to teach and learn online. So Renate, the next 40 minutes are yours. Please leave some time for questions at the end. Please enjoy the very useful and informative presentation.
Thank you, Ivan. Thank you for the introduction. So I would like to share the presentation with you. Okay. Is it visible for you? Okay. Yes, I'm a little bit sad that I cannot be there in person, so I try to give my best here now with the online presentation. Yeah, good morning to everyone. I hope some of you are here. I know it's very early, I think also for you here in Spain, and you have had very hard days before. I listened to some presentations of you, and I think it's a very interesting symposium, and I hope you can uh, pick up a lot of new interesting things um, for your teaching at home at the university. So what I would like to present you is it's not a specific mathematical the topic, so I'm not a mathematician, but what I can do or what I hope to do with this presentation to give you some ideas how you can work with online teaching. I will present you the concept we are working for a long time, long before COVID here at our university. It's e-moderating, a framework of teaching and learning online. So I have to check how I can. So, yeah, now. Yeah, okay, yeah. Where I am now, I'm in Tirol, in Austria, and I hope we can invite you also here at our university during this project. E-moderating and online learning. I will go over some steps here at the presentation. First, collaboration, online learning, why and how. Then I would like to present you an example of our master study program where we use this method and what we have learned and what's the conclusion. Yeah, first, let us remain how learning occurs. Yet basic learning theories based on behaviorism, cognitivism, and constructivism. What is behaviorism? Knowledge is, so the idea is knowledge is exists independently and outside of people. Learning occurs through the association between stimuli and response. Classic here is the example of from Pavlov, the Pavlov's dog. So you can learn and then you get positive or negative reinforcement. Then we have the theory of cognitivism, so humans process the information they receive and to think about what's happening. Learning occurs through international processing of information. All activities will be embedded in the information process of students to active, reflect, and repeat. But what we are focusing on now today is on the theory of constructivism, and the very interesting basically is here that that the assumption is this human construct their own knowledge. I think we, uh, as I followed the presentations before, some of the aspects you discussed, how you can active students or to actively involve students in the teaching and learning process. I think it's based on the constructivism idea or theory. Mm, yeah, let's um, here a short some yeah illustrates what is constructivism and what's not. Um, the 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 idea is that knowledge cannot be transferred from the teacher's head to student's head, like this picture up. Uh, and so knowledge needs to be actively constructed. That's the idea behind. But we have also to consider, and that it's why we say social constructivism, but we are all social being, and we the didactical principle that I would like to present you today is on also on that we have to consider also that we socials, and that that's the reason why we call this, otherwise it's called in the literature social constructivistic learning theory. As a learning is a constructive and social process. That's the assumption. Learning works best in communication and collaboration with others, and learning is an active process, and learning is also a emotional process. Um, what's the advantage of active and collaborative learning? Um, better knowledge retention, increase motivation, engaged learning, integration to different perspectives, identification of own gaps in the knowledge, and deeper content processing. That's some examples for advantages of active collaborative learning based on the theory of social constructivism. For collaborative learning and teaching, the learning environment is essential. You have to build the opportunity to foster collaborative learning. Teaching in person, indeed by teaching in person, you have to change, as you see here, the traditional learning environment also in a collaborative learning environment. When you look at your university at home, most of the environment for learning and teaching is constructed uh, in the traditional learning setting. So you have these big rooms, and I think you sit also here in this room, like the traditional learning occurs. But it's very essential that you have to build up collaborative learning environments. But now we have a next challenge. How can we do collaborative learning in an online setting? And that's this what I would like really to discuss with you today, but of course I would like to present it to you. How can collaborative learning done here in this online environment? Is it possible? How is it possible? And how is active learning supported? Here, first we can here um, take a look at the continuum of learning, of online learning. As online learning have can do it face to face. Online face to face learning is sometimes also called online learning. Some materials are provided maybe in different learning management systems, and students come to the uh, to the university, and sometimes you use this learning management system to yeah, to work on it, but it's it's a face-to-face learning. Then with the concept of blended learning, it's a mix of face-to-face and online, and then we can say, and then it's one part is online-based learning. And what I would like to present you is how can collaborative learning occur in a fully online-based learning. What is the advantages? What are advantages of online learning? So online learning is independent of place and time, individual time of learning, so students can decide when and how much they learn, and integration of multimedia information sources only for some examples. Here are some examples for online learning. And the next is that we have to take a look on different types of online-based learning. When we talk of fully online-based learning, we can here divide this divided in three types of online-based learning. One is the synchronous online learning, so that I think we did this a lot in the last 2 years, like in synchron online conference or online teaching with videos, webinar, chats, and so on. But it was synchron, so that means that online learning is together with the students the same time. And then we have the opportunity to do online-based learning on an asynchronous self-study online. So I think you did it also to give them videos to show, or they can read an ebook and so on. And what we are now focusing on is to discuss how asynchronous collaborative online learning. I think that's really the challenge when we will use the online environment for collaborative learning. So the learning activities, you have to use learning activities, discussion forum, peer feedback, exchange with experts, wikis and blogs, and here only some examples, methods you can use for asynchronous collaborative learning. Yeah, now I would like to present you two models of online-based asynchronous teaching and learning. That these both models we are use, or that's the basic ideas we use for our fully online master study program. One is the community of inquiry von Garrison et al., and one is the Salmon's 5-stage model from Chile Salmon. What is the assumption of the community of inquiry? The model of this community of inquiry assumes that learning occurs with the community through the interaction of three core elements. So interaction is a very specific part of it, and the interaction occurs between social presence, cognitive presence, and teaching presence. What is mean with these elements? Also, first is social presence. That students can, in an online environment, and that they are not synchronous or they are asynchronous, so, and they are in different places in the world or in different places in Europe, and um, that they can also be part of a group. That's very important. So that's what's called social presence. So that they feeling to being part of the study group, that they can that this is about trust that they build up in the group, that they have a positive feeling that they can ask stupid question or make mistakes, and that they have the feeling that they are knowing each other despite they are only asynchronous and online based and wherever in the world. Um, the next is teaching presence. So teaching presence means it's how can a teacher, teaching presence is that was the presence of teachers to foster learning, to facilitate critical discussions. It's the presence and the role of the teacher. And the third is the cognitive present. It is extent to which students are able to construct meaning, sustainable communication and reflection. So these are the three basic elements of the model of Garrison and all. It's called community of inquiry. And the next is the five-stage model of Salman, Chili Salman. First is so that they can get work and they can get socialized in a group. She described 5 steps. So first is the access and the motivation, also setting up with the systems, welcoming, encouraging. The next step is the online socialization, also sending and receiving messages. And the third one is information exchange, also tutoring and supporting use of materials. And the 5 steps here is the starting of beginning constructing knowledge, and the last, the fifth, is then development. It's providing link and materials to others to give them in the group new ideas and support them together. Mm. Now, let's summarize. Let's have a short conclusion before I start with the examples for you how we do all these theoretical or how we integrate all these theoretical frameworks and models in our study program. What's the conclusion? The way of learning. So evident is that course engagement and interaction with peers are related to better learning and outcomes. I think that's what you discussed all the days before in the section. Especially important for online-based courses is this course presence, to be online in the course participation, to be active in the course, reading and writing, and course interaction, to discuss actively with peers. So I think that can here summarize these 3 special important things for online-based courses. Yeah, now to put this all in a little bit practical example, I will present you our online master program for health information management at our university. We started 2017, so long before COVID. And I can say COVID occurs and nothing has changed in our study program. That was, we were very lucky. Oh, sorry, I have now, I think, a problem here. I don't know why the slides not going on. I would like to stop short and then I would try it again. I hope it works. Sorry. I don't know what happens. Yep. Doesn't work. I don't know why. Sorry. But that's very bad. So I would try to go to the course directly. Then you can see how we do this.
Maybe showing it from the outside of the presentation instead of inside. It will work.
What my computer doesn't work, so that was this. Now I can close the session. I can't close my presentation. I can't do anything. So I don't know.
It's fine. If not, maybe just give us an insight on how it was, and maybe you can send it later to Drive, and we can all check it.
What I can do now is to open the course, the online course. Then you can see what I would like to present to you. Okay, you can see this here now.
Yes.
Yeah, okay, so I have to do a little bit improvisation, so I don't know what happens. So I will explain you now how we do this course. One course in this master study program is for 6 weeks, and it's and the basic instrument to guide the students to the course and that they can really actively work in this course is that we work with activities. Activities, that's very that's the key elements, and it's also these activities is also described by Chile Salman, and it's the key elements that really students can work together and learning together. It's an instrument that the e-moderator, it's like the teacher, so it's called e-moderating, that they can really efficient design a task that students can work, and that students can be engaged in learning and that they can be productive in this course. So it's the key element. And what does this and these activities all have always the same structure. And first they have a number here, you can see it here, and they have a goal or purpose what they have to do. They have briefly summarize the overall task. Um, to There is a spark in it to light the fire of the topic. They do what they have to do at the individual contribution, what they have to do in the dialogue, and the e-moderator intervention, what does do the instructor role, what is his role or her role, and the time what they have to do. And here you can see one of this example. Um, First of the 6 week, and it's also based what I said before from Salman in the 5 stage. First, they come in the course, and it's new, and they have to get together to socialize, and we always start, and it's with that they have to think what is their knowledge about this course they gained before, or they have it from another, like when they work in field and in a working place and so on. So first they have, you can see here, they have to uh, to, to to work at the first activity, to start what do I want to know, and um, what do I know and what do I want to know. So here is a short introduction. Watch the video below and think about which of the problems mentioned have to you already encouraged in your work, which topics do you already know about, which content, and so on. And the goal is be clear about your own prior knowledge, and then please write a short post, and the dialogue begins. Read the contribution of the other participants, and so now it's the important part to be active, and that they can collaborate, or that they have to collaborate, to see both in which you find similarities with your personal learning goals and your interesting aspects, and so on. And yeah, one of the students already starts to work. Then you can show, okay, he has and that's his contribution, and now the others have to answer and to give their to find the similarities and to discuss about this topic. And yeah, that's one example for for one of one course works, and it starts with this, and the last one is immer that they have to reflect over the weeks. So this is over the weeks, and the last it ends after 6 weeks, and after 6 weeks they have to do the conclusion and the reflection. So that's what we that's all of our courses are based on these theories. And yeah, what have we learned? That we can motivate and engage students, that we have good learning process, that they have a good group feeling. What I can say is, as a e-moderator, as a teacher, I do it, I think it's in 5 courses, and I have never seen the students, but I know them very well, I think so. We have students from all over the world, and they have never seen, but they are a very good group together. They uh, they they get friendships, and it's very interesting to see how collaborative learning works in an online environment. Yeah, what have we also learned is that we have to training and coaching of teachers is very essential. Then it's a very high workload for the teachers, is 24/7. So I never know when students discuss, do they have a question on the teacher? How can I a very important role is that you always look what they are discussing in the chat rooms. So sometimes you have to give an advice when you think the topic is not correct, or they have to consider other aspects of this to these topics, or give them sometimes an advice for literature. Yeah, in this period when I have this course for 6 weeks, I really work 24/7. But some other the last course, I did an agreement with my students. I don't look at their work on Sunday, so I decided to have free on Sunday. Yeah. Um, yeah, the conclusion is it works good. I think what we also learned is now for the in the crisis for the other courses, we can also use some aspects of the concept when we now moved to online learning, and um, and I think in our university now all institutions are um, uh, take some of these your recent aspects to construct their uh, lessons. Okay, sorry for this technical problems, and now I'm happy if some of you have questions.
Thank you very much, Renata, for the very thorough and thoughtful presentation. Any questions, please? Does anyone have any questions here or online as well? I was wondering myself when you spoke about approaches to online teaching, because we have been facing that for 2 years now, and it's really difficult to achieve interactive lectures, and it's even more difficult to make sure that the attending students are actually listening to us rather than simultaneously browsing the web or watching movies or whatever. So can you maybe emphasize for us approaches to make sure that we have the attention of the listeners when they are online? We just see a list of names that are online. We don't see their videos, or we don't see, are they really there in person, or just the computer is signed in and they are still asleep?
Yeah.
So what approaches can we achieve? What approaches can we use to make online teaching a bit closer to real life teaching, which is, I guess, irreplaceable?
Yeah. That's the problem. I think online teaching, it's more boring than teaching in classroom. And yes, you have to. What I can say is that you have uh, to try that they have to be activated. They are activated, and they have to do uh, and to work for their own. And what I can recommend also for, we have had also the same situation, not the other study programs also moved, and we tried first to give the lessons here face to face, online face to face. So, but we decided quickly that we use the same idea that we have in our other fully online master program, and we designed these activities, and we give them the, the and we encourage the students to actively work. But what we did is not in this fully asynchronous modus, sondern we we divided one day or the lecture in for 2 hours. We present the activities, what they have to do, and we used also the discussion forum. We when we had a big group, we divided this in small groups, and then at least of this lesson, we summarized um, what their uh, uh, what they worked on their topics. Yeah.
Another point of uh, discussion, at least in my staff meeting, is the recording of lectures. My idea was in general that it's good to record the lectures so that students can go back to the recording whenever they want and replay parts that they need clarification for. So it can be used. One of the benefits of the pandemic was that we generated additional learning materials that are available online for posterity. But there was another point of view by colleagues that you can always find online better presenters and better lectures on the same topics that we are teaching. So it's not the recording that matters, but they insist on not recording the lectures so that students actually attend the time slot provided for the lecture and try to make the most of it and try to pay attention and to ask and to participate in the lecture so that they take from the lecture more than if they are in the comfort zone knowing that the lecture is being recorded and they can always go back to it. They don't really appreciate it or pay attention or attend the lecture. While recorded lectures can always be found online on the same topics from more eloquent teachers maybe. So they were opposed. A smaller portion of the teaching staff was opposed to recording the lecture. What's your view on that?
Yeah, it's always the point of the goal, what you would like to, what would you like to reach. So we had the same discussion in the other study programs. Um, when from the perspective of the constructivism learning theory, yes, recording and that the student you provide and to provide the students the materials and the lecture, and they can go over this lecture how often they want, or they can compare it with other materials they found in the internet. And but uh, the important is that they have an an, an, they have to an activity, we call it, or an active part, what they have to do and uh, what they have to, in the end, what they have to learn when they listen to your lecture. And that is what the idea is, that knowledge construct in our mind. So not only to listen, sondern what in the end, what should I know, what have I to do, and what can I add, and how can I show that I know what I what knowledge I gain now. I don't know if you can understand what I mean. So only to provide and only to provide lectures, I think it's not so.
Yes, please. Laurie also has a question, so it's ladies first, please.
Hi, Laurie.
Thank you. Hi, Renata. I'm also from far away. Thank you very much for your talk. You said you started to think on online course in 2017. I understand this is a master program course. So did you start also thinking about this for more basic courses of first year and second year, say? Or if not, then did you find that, did you apply the same principle when the corona came, and did you find that the same thing would work?
We did part of this principles in the other courses when Corona occurs, and we did a mix of this. this what we do in the fully online master program and what we have done now in the online lessons that we have to give for the other study in the other study programs. I think what we would like to know or I can what I'd like to hear is that does this work also for the young students? They start with
Yes,
the,
because they do not have the experience of learning that master
yeah,
students have.
yeah. I think it. We have. I don't have this experience. We don't have this experience. But though we are at our university, we have also a little bit special groups. So we are a private university with small groups, and some of the students are older. And so I can say, it. But I think it could work. But you have to do. I think it will be take more time that the students learn how to how to learn in this
Right.
in this environment.
Okay.
But I'm honest, I don't have this really this experience.
We have one more question here before we proceed with the next presenter according to our schedule, please.
Just one comment. I would like to state what Renata said, but even more directly. If you give a lecture and your students decide that there is an online lecture that does the job better than you, then perhaps as a lecturer you could have been using the time differently and better. It's our responsibility because these resources exist. So this is fantastic. Now what can we do with the time that we have?
Thank you very much.
Yeah.
We have to proceed with the next presenter, Jiri Hotzman.
Okay.
He
So
comes.
bye. Have a nice time.
Thank you, Renate, for the presentation. Thank you for the participation. We enjoyed it. So Jiri comes from just next to Austria, from the Czech Republic. His presentation will be on real-life problems within the medical imaging systems courses. So, please, the next 45 minutes are yours.
Thank you for your introduction. So, good morning, everybody. So, at first, when I will start my presentation, I would like to tell you that I have tried to find some more suitable way how to present some our selected experience as regards the interdisciplinary approach. So, I am not a mathematician. I am typical application engineer, and I'm cooperating with a lot of hospitals. And from this follows that we have to use a lot of practical examples as some suitable motivation for students to increase their motivation and to increase their relationship to solve some requested tasks. So I will start my presentation. So I think that you see my presentation, that's right? Okay, so...
yes, we can see the presentation. It's okay. Please continue.
Thank you. So as regards the course medical imaging system or systems, so it is a relatively wide range of topics, and there is a lot of very interesting subtopics which are very suitable for support of some visualization of some manipulation with mathematical equations as regards the close connection to the clinical practice and so on. So I have selected only one very simple subtopic, which is called lookup tables. Maybe some of you know what does it mean exactly, but I would like to perform some gentle introduction into this topic, and after that I will show you what kind of tools can be used for better understanding, better illustration, and better utilization of. Sorry, it's my colleague. Sorry, it was mobile phone of my colleague. Sorry. So as regards the outline of my presentation, there is a few topics. So I think that so I'm very sorry. So it means that the most important part will be devoted to the illustrative applications using the lookup tables. So as regards the motto, so because of I am teacher of the medical imaging system, so I will use suitable number of pictures because of as we know, so the information from the picture is more suitable than a lot of pages of text and so on. So from this follows my motto that one image is better than thousands of words. So as regards the real life problem solution connection with this subtopic, so you can see here what kind of everyday life procedures are connected with such topic. So, for example, in case when during the COVID situation, there were evaluated some CT images as regards the lungs. So there are used special oriented lookup tables for the better visualization. So as regards the mobile phone, so they are used the so-called lookup tables, but it is belong our will as regards the PC graphic card. Yeah, so it is a very important part of the PC or of the computer. And within the internal structure of this PC card, there is used lookup tables as well. So, and the last one is some kind of just CT images from the special kind of the modern CT, where is required to set appropriate contrast. So, as regards the main aim, so I think that in brief, it is approach from some idea through some mathematical equation, some visualization and manipulation. And within this step, there is very important immediate feedback from students. Yeah? As regards the any kind of teaching, as regards the self-teaching as well. So, and the next level, it is some clinical application, and after that, there is included some manipulation as well. And this circle of these procedures can be repeated based on the request of students or teacher. So it depends on situation and course. So as regards the mentioned gentle introduction into the digital image, so I would like to start this introduction with some simple block scheme of acquisition process. So here you can see some typical situation when some TV camera, which consists of lens, ARA emit sensor and electronics, is able to sense some grayscale image. Within this case, it is some test image. And the TV camera is the most important item of this chain because of within this camera there are performed three main principles for the TV scanning. So it means that the composition into the matrix of points, it means matrix of pixels, as you can see here. So the next is a conversion of the incident light, it means brightness into the electrical voltage. So, and after that, there is performed some synchronization with the connected computer. So, as regards the end of this process, so there is very important conversion from 3D scanning into the one-dimensional electrical signal, and this analog signal is introduced into the special card within the computer, which is called analog to digital converter. And by means of some drivers and software, there is possible to perform some synthesis of the sense image. So such kind of the image is saved as matrix of some numbers. So in general, when we will take into account some physiological range of the human eyes, so it is in majority cases the range from 0 black to 255, which is white level. So as regards the image which is saved within the computer, so just imagine, for example, this example, and we have to determine exact position of such pixels. It means XY coordinates, and based on the position, there is some functional value. It is IXY. So, and in the case when we will perform some conversion to the computer, there is some conversion to the discrete points called pixels. It means picture elements. And we can see here some matrix rows, matrix columns, and functional value depends on some parameters. So as regards the other possibility how to view the image, so we can see the image by this way, for example. So it means that it is some kind of the perpendicular view. It means from top view. Yeah, so you can see some lines with different values. So it is the same image, but from the different angle. But from these angles, there is a very illustrative view as regards the content of the image matrix. So as regards the image or digital image, there are very important two basic aspects. It means image resolution and number of gray levels. It will be very close to the lookup tables, which was mentioned at the beginning. So on the left column, you can see different spatial resolutions. And as regards the second column on the right side, there are two columns. So there are illustrated different kind of gray levels. So as regards the difference, so from this point of view, there is very important to compare, for example, two gray levels with other images because of the very illustrative and very big difference. But in a case when we will go to the next slide, so we will see that these differences between the 32 gray levels and 256 levels. So for the first point of view, there is no difference. Yes, so that's right that within the detailed processing and within the file which is saved on the disk, there are different data. That's right, but for the first point of view, it doesn't such different as was proposed. So as regards the LUT concept, so as I told you, it is a lookup table, so it is some kind of the for example, phone book, and it is connected with some simple idea. When you have two images, it means image A, image B. So in such case, this point and the same xy position have some relationship based on some operator or function. So it means that this operator or this function is called lookup table, and we are able to determine the value within the B image based on the value within the A image as input and based on the functional operator. So it is called in general point operation. And for the better understanding, there is a very useful concept of slow intercept form for a line equation. So it is very known for students. By the way, this concept is very suitable for the illustration and explanation of the brightness and especially contrast. In a case when there will be some question, what does it mean contrast as regards the images? So this approach is very illustrative and very suitable to how to explain it. So as follows from this slide, so there are very important two parameters. It means slope of line, it means k, and q as y-intercept. So it means that we can use some general concept for images to have such a specific lookup table where on the x-axis there is used input pixel value. It means from 0 to 255, and on the y-axis there is output value. It means value from the image B. So it means that the line is a function and operator which is related to input as A and to output as B. So within this example, it is a simple copy because of any input value by means of this line will be transformed to the same value at the output. So it means that it is a simple copy. Yeah, and from this follows that there is k equals 1 and q equals 0. And now we will use this concept for some other approaches. So here you can see some other examples. So here we can see some the most known examples of rules, especially for adjustment of the brightness, especially for the contrast adjustment. So it means that there will be very useful to design, develop some tools by means students will be able to verify immediately such concept. And we will see later within this presentation that it is possible independently of the kind of the teaching. So as regards the next example, so there is relatively wide varieties of such lookup tables, and there is very important that to design and prepare such routes requires some other mathematical knowledge and some experience, but for students it is the standard. So here we can see some typical implementation of the lookup table. So just imagine that we have some input image with some discrete values within the range from 0, which is black, to the 255, which is white color, and other are gray levels. Here you have the so-called phone book, for example. It's some analogy of the lookup table, because of here we have some address, and here we have some value of the memory cell. So it is the same as in phone book, there is some name and phone number, or something like that. So it means that if we can use this approach, for example, for negative, so it means a negative means that the input value will be converted to the opposite value. It means it is white, so the opposite value is black. So it means that the address is this value, input value. After that, there will be found output value. It means after the conversion by means of the loop, and this output value will be saved within the output image within the same position. So we can see some approach by means of the circles. So for the better understanding, I will try to show you some relationship with complete images. So it means that there will be illustrated application of some kind of the mathematical operations. It means constant addition. It is brightness increasing, as you can see here. So it means that it is before the operation, it is after the operation. So, and now within the second slide, you can see very important relationship concerning the lookup table before, and after. So it means that students are able to test, and to evaluate immediately what will be performed when we will use other setting of the lookup table. And we have here some histograms which are very important output, and it is a very important sign about the visible range of the images. So the same approach we can use for subtraction, for example. So it means that it will be decreasing of the brightness. The next one is multiplication of all pixels by some constant. So it means that it is increasing of the contrast. It is very important operation, and there is very important change of the histogram. And the last one is application of the division of constant. It means the result is a very low dynamic range of the image, as you can see here. So within the next slide, you can see the first clinical application. So it is a DICOM image which is used within the everyday procedure as regards the imaging system within the hospitals. So, and our students have possibility to process such images, and we can see here some detail within the metadata which are included within the DICOM. And here we can see some very important text which is called rescale intercept, rescale slope, and rescale type of units, which means Hounsfield unit. So it means that in case when you have here such value, so we are not able to use the standard approach within the left. So we have to use the, the new route, which is related to such parameters. So it means that the new position over the line is here. Yeah. So it means that the slope is 1 and intercept is minus 1024. So the next example was prepared within the light microscope. So it means that there was a set very closed iris. Yeah? So it means that low light level conditions. And here we can see application of the standard lookup table. Yeah? But in case when we have this very bad dynamic range within the histogram, so there is unsuitable utilization of such route. So this route has to be modified, and the result is here. So it means that on the histogram there is nice that the whole range is spread after the whole range of the input values. So as regards the relationship, general relationship of the histogram and lookup table, so here we can see some simple example. It is typical lookup table, but for some examples, as here, for example, so it is very short dynamic range. So it means that there is required to match the parameters of this line, yeah, to be by such way. Yeah. So it means that we can see by this simple example how to derive the values which can be computed. So it means that there is possible to evaluate Bx value based on the Ax and other limitations. So the first tool which was used, it is software, medical image processing software, which was implemented a lot of years ago by me and by my students. And here we can see some example input image. Here we can see some menu regarding the changing of the route. So it means that there is possible to select appropriate route. Yeah? So maybe I will try to show you how it works. So maybe you know some window of our application. So here we can apply a lookup table function we can select appropriate one. We can select view histogram, and student has possibility to change, and there is visible immediate feedback as regards the change of this. So I will go back. So, and the next second example, it is some educational video which is close to the topic of visualization of the CT images. So there is a very wide range of measured values. These values are called Hounsfield units, and this range is wider than the standard physiological range. It means 256 values. So from this point of view, there is required some matching, and this matching is performed based on the related tissue, and there is required to see selected tissues by means of some window. So from this follows that we are not able to see all tissues in one time. So it means that medical doctor has to change the level window to see appropriate tissues. So as regards other examples, so here you can see some standard M script in MATLAB where it's possible to illustrate the problem of the root. It is the continuum of such example. Here I have prepared some application designer example where it's possible to perform some interactive manipulation and visualization of the parameters of the root. Yeah, and there is a histogram visible as well. So it means that it is very appreciated by students that there is immediate feedback. So here we can see some other example created within the Mathematica. So it is the same concept, but by other change. So there is some general function, and we are able to change the exponent of this function. So at the end of my presentation, you can see here some advanced applications. On the left, you can see some segmentation of the mouse lung airways, and on the right, so you can see some segmentation of the mouse brain soft tissue. And as you can see, in some cases, there is possible to see both tissues, not only vessels, not only heart, not only brain, but both. And in case when it is illustrated by means of the micro CT, where is used X-ray radiation, it is very important because of X-ray radiation has a very big drawback as regards the visualization of soft tissues. So it is some last example concerning the very interesting application of the lookup table concept. So on the left, you can see some 3D sample common with cylinder mold. And our task was to see only the internal part of the cylinder. So it means that it is based on manually root based. And here there was possibility to apply some fuzzy approach for the better setting of the root. At the end, I would like to tell you that I have a very good experience with this approach because of these tools are available for students in any time. There is immediate feedback, and I would like to express many thanks to Dr. Feuerstein that I am a member of the CTU ITEM team, and I hope that our outputs will be very useful for all of you and for other students. So at the end, here we can see some link where you can download some examples, and in case then it will be useful for you, so we will happy. So thank you for your attention, and I'm prepared for some questions.
Thank you for your presentation. A short applause would be appropriate. If you don't need a break, then I guess we can continue with some discussions. Do we have any questions from the audience, please? Both online and the ones in the auditorium here. So my experience with image processing and recognition of different tumors and stuff in the image processing is that usually the classifiers are a black box. We used to use support vector machines. Nowadays, deep learning is popular, but the classifiers will not bring any knowledge to the doctors. It will only give them classifications without explainable AI. Do you think that nowadays we have tools in image processing that can give doctors advice on how to recognize previously undetected shades that could maybe be tumors? Or so, because explainable AI nowadays is a very popular domain. Please.
Yeah, you are right, but there is required to prepare and to do some training of medical doctors for such approach. So there is no possible, for example, one day to install some AE application within this single wire, and the second day to start to use such application in a standard procedure. So from this point of view, we have some approach to train our students because we have possibility to place our students as biomedical technicians and biomedical engineers, which have such responsibilities as regards the AI. And by such way, I hope that it will be possible to train step by step, within some hospitals, some group of medical doctors. But it is a relatively long process. But from my experience, medical doctors are very interesting or are very interested in this topic, and they are prepared to be trained by experts. So from my point of view, it is solution.
And one more thing, because this is a conference about enhancing mathematical education with problem-based learning and real-life examples and so on and so forth. The mathematical background of the algorithms we use in image processing can be quite complicated, and when you teach students about them, you should always make the decision whether to go into details of how support vector machines work, or how deep learning works, or what's the mathematical framework for neural networks. On the other hand, you should teach the students how to use the tools that are readily available, the tools developed in Python for application of deep learning without knowing the background. So how do you balance between theoretical foundations of those algorithms and easy applications of readily available tools and frameworks, and it's even available nowadays online with JavaScript libraries. You can just upload your photo and you'll get results. So how do you balance, because you have 1 semester to teach them, how much do you spend on matrices and the basic algorithms for conversion of images with Fourier transformations and cosine, and then actual tools? Thank you.
The common answer is that it is a very wide question, and this question has a lot of solutions based on the approach. Yeah. But from my point of view, there is required to use very good background of the medical doctor and a very good background of the engineers. And in case when there is required to work in team, yeah, there will be possible to find some common line. So there is no problem. For example, in case of the artificial neural network, so medical doctors or they have a very good background within the biology, anatomy, physiology, so it means neurology. So it means that they know very well the principle of the artificial neural networks. And as regards the algorithms, so there is a very important task for engineers to use some analogies, yeah, which will be understandable for your colleagues within the hospital. So I think that every expert has to use appropriate background and tools related to his background. And after that, there is required to find some common dialogue, yeah, and from every side to use some analogies which will better illustrate the solved problem. So I have such experience, but you are right that it is a very complex process, and there is only part of medical doctors which have some interest to go more deeply, yeah, within these topics. But I think that it's a relatively nice cooperation.
Thank you very much. If we don't have any more discussions, according to our schedule, we can wrap up this part of the presentations. I would like to thank Jiri Hosman for his presentation, Renata as well, and we can move on to the coffee break. Thank you very much. Another round of applause.
Thank you.
Thank you. Have a nice rest of the day. we will hear the presentation by Vesna Dimitrova of a paper titled Analysis of Student Surveys for Using New Technologies in Improving Mathematics Learning. She co-authored the work with Alexandra Popovska-Mitrovic, Boban Yoksimovsky, and Ivan Chorbev. Please, Vesna, the next 40 minutes are yours.
Hello, hello.
Now it's okay? Yeah? Okay. Thank you. Okay, my name is Vesna Dimitrova. I come from Faculty of Computer Science and Engineering, St. Hilary Methodius University in Skopje, North Macedonia. Today, I will present our analysis and result of the student surveys for using new technology. We made 2 surveys, and both of them are for to see how a student think that is better to learn and teach mathematics. This survey help us as a teacher and also help for student for take some direction for using new technology and teaching mathematics. Okay. Outline of this presentation. First, I will say something about our idea, about our surveys. Next, about the methodology, results obtained from these surveys, and some conclusions. Okay, we know importance of mathematics courses in solving real-life problems and application. Know that this is very crucial, this is important, but there is some but. Some students of computer science and engineering do not recognize this usefulness of mathematics for using for other fields. They do not appreciate importance and the role of mathematics. And also, some of them think that only hands-on programming and software knowledge is enough for computer science engineering. Okay, we will see what they think about mathematics and what they think it for their side is good for teaching and connecting mathematics with real-life problem. Okay, learning math has many benefits, and this is the reason why we made these surveys to see that these benefits has such as power of reasoning, creativity, problem-solving ability, and some other. Okay. This research, I told you that is the research in order to improve, to see from a student side, to see how they think and using their result to improve the way of teaching and learning mathematics courses using some mathematical software. The first survey is student opinion about using GeoGebra, and other is some direction for from their side to see how they think that is easier to learn mathematics. Through these surveys, we will try to give some recommendation for improving. First survey is for the experience of using GeoGebra and other similar. We have question how many tools they use, or is it only GeoGebra, or they know some other similar application. And from the second survey, from the student answer, we will see their opinion and suggestions for improving the lecture. Okay. Here is our methodology. 4 years, yes, 4 years ago, we use Mathematica in calculus. For the exam, students have 3 parts. One part is the exam is 45 points of the final exam is for theoretical questions, 45 points are for exercise, and 10 points are for lab exam. It's not mandatory. And for this part, for lab exam, before, 4 years ago, we used Mathematica. And after that, we saw that we have a problem with license, and then we switched Mathematica to GeoGebra because it was free software with same possibility. And we made some analysis when we switched to this software, these tools. We made some analysis from the lab exam January. This was first exam in these years. And we analyze from these 10 points how many students. We have total 167 students. What is the result? And we can see then that almost 90% of them scored more than 6 points. They passed this part. And almost 42% have 9 or 10 points. This is good for us because they, from the survey, we can see that for them, GeoGebra is okay. They understand, they can use it for solving real-life problems. Now we can see the result for the first survey. We have 5 questions for this survey. We have a group of 42 students, and we can see their answers. First question was, how GeoGebra help you in learning the material for calculus? We did this survey for calculus. And here is the answers. We can see that almost more than 52% of them tell us that GeoGebra help them in learning the material for calculus. Okay. For the next question, how difficult is using GeoGebra for solving problem for calculus? We can see that only for this group, only 3 students say that it's difficult. Others say it's average, easy, or very easy. On the next question, have you used other mathematical software except GeoGebra? Almost 20 students of these say that yes, they use some other, but for most of them, GeoGebra was this software, and they didn't use other software. Okay. The fourth question was, would you still use GeoGebra to solve mathematical problem after that, after the exam? This survey was made after the exam. They say yes, and almost all. We can see that maybe 20 of them say no, they use some other software. We can see on the next question, does mathematical software help in the learning? And here, if they answer yes, they put what other software. And from the answer, we can see that some of them use Mathematica, Desmos, Symbolab, Photomat, and other. This is some, yes. So here we can summarize all of these questions. We can see that GeoGebra help in 52% of the students to learn easier the material, the solving problem. Only 6% of the students have difficulty in using GeoGebra for solving. For a group of 22, I think that is very small number of students, 3-4 students. The question, what other software they use, this question was answered from 19 students, and some of them, 7 students, used Mathematica, 5 Desmos, Symbol Lab 9 students, and 1 say that used Photomat. Most of the students, more than 70%, say that usefulness of math software and would continue solving and using this software for solving math problem, and use them in other courses, not only mathematical courses and other courses in their studies. Okay? This was the first survey. About the second survey, this survey is more for us, for teacher, to see some direction, how we can improve our teaching. We can see from the answer that students really want to see the part of calculus we teach, where they can use it, in which subject, in how they can use it for solving real-life problems. This questionnaire was filled by 21 students. We have, again, 5 questions. First was, in your opinion, are the math teaching hours enough to make you confident in the subject? Calculus, for calculus, we have 6 hours per week, 3 for theoretical lecture and 3 for exercise. These 3 for exercise is 2 for writing exercise, and 1 is for lab exercise, using lab. Second question was, in your opinion, which modules or themes of math courses need to be updated for determiners, which means which also this is for calculus. This questionnaire was filled by students in, they have calculus. Third question was, what difficulty did you face in learning math subject? Fourth question, do you think that examples from science, technology will help you better understand mathematical concept? And the last one, what solution do you suggest for improving teaching and learning math courses? Now we will see the result from each question. From the first question, the result was that 57% of students think that math teaching hour is enough. It is 6 hours per week. They think that is enough. Some of them think that is needed more mathematical hours too. Okay. For the second question, most of the students think that for a better understanding of the material, more practical examples and exercises is needed. We can see some of the answers of the students. We can see that they need more exercise, solving more tasks, exercise to be better explained, lecture that are more applicable in everyday life. This is some of them, lecture with which students are introduced to mathematical concept and their application. I think we should have more exercise. You can see that all of them want to have more exercise. Theoretical, they say, in some other answers, they say that it's okay, theoretical aspects, but we need to see how they is connected with real life problem. We need to see how can we use this for solve some problems, okay? The same result was for the third hour questions. What difficult? They say that theory and they want to connect. I put here for only 4 of them. They want to, for every lecture, they want to see visualization. They want to see how really can solve this with using, for example, integral or using derivation or some other theme. We can see problem with theoretical part. Why? Because they want to see, okay, now we can learn integral and how visualization. Now, this was our first research. The next Boban show the results from our second research, and there we put some visualization, and students are really happy that they say that this is the better way to understand mathematics. Okay? Okay. For the next question about the examples from science, from technology, do you think that these examples will help for better understanding? Yes, almost 76% think that this will help. Yes, learning would be more productive if students say, saw a direct connection to what they learn and real life. Yes, we need to know why it is being used and why we are learning the subject. Okay, also from the last question, here is their opinion and their some direction, how they think, the suggestion, how they think is, how from their side, how can we improve our teaching and learning for them, how some direction for easier learning math courses. From the answers, the student gave interesting comments, suggestions for improving, but also, I will say, we can see that in all of these questions, they say we need more exercise, we need more visualization, we need more connection with real life problem. This is one of the topic on item project, and we can go in that direction. More focus on practical teaching, the application of this material, more exercise, things related to real life. Okay? More task with an application to everyday life, practical exam, not just theory. I say this was our first research. After we put a visualization, we obtained other results that Boban showed 2 days ago. Okay? And we can conclude from the first survey that yes, students have benefit from using mathematical software as a tools for learning, for understanding materials, and our recommendation is that we can use this software for better presentation, for better visualization of the material, and for easier, for students, for them to be easier to master the materials. Okay? Okay. From the second survey, for students, it is really important to understand this connection between math courses and real-life problems and their application. We see that more students want more exercise, more tasks for solving practical problems. And we can see that this survey shows us that not only for the student, this survey helps us as a teacher to see what is the better way to teach this what students want to learn, what way is better for them to understand the material. Okay? And finally, we can notice this benefit, not only from students, but also for teacher, or for the aspect of student. They will increase their ability to learn and apply mathematics, to realize the application of mathematics, to solve the problem, to see how they can use this for solving problems. The second one, for teachers, we can improve. We have some direction how to improve our teaching. And now, because I'm one of the professor of calculus, after this, usually I talk with students, I put some examples, some examples of data mining for robotics, artificial intelligence, application in machine learning, etc. Okay? Thank you.
Okay, thank you very much. Does anyone have any questions? Please, Kostas.
I would like to ask you, how are you going to check the impact of your policies towards better learning and more efficient learning of your students after you address what do they want, if you have already addressed what do they want? So you have introduced visualizations, real-life problems. How do you evaluate the impact of your actions to their learning? They want, you are acting, how do you evaluate this?
We can evaluate also using this the exam. Oh, maybe. How we can evaluate?
Yeah, I mean, you made, these surveys. The students, they respond that they like this or they would like, more things.
Yeah.
Then you act, you provide, the services. Am I right?
Yeah.
How do you evaluate the impact of your policies? I mean, what parameters do you check?
Maybe we can see. I think it's better to evaluate this. We can compare maybe this new for these courses with previous in one way. We can compare.
But the same person or different persons? Because if the audience is changing.
Sorry?
I guess we can do new surveys and we can check the increase of
But
yes.
Okay. So you will check.
If the throughput of students increases, we have positive effects. If the percentage of students passing the exam decreases or is stable, we haven't done anything.
Okay, so you will check the exam.
Yes, the throughput is the best and the average grade, I guess. If we have an increase in the average grade or if we have bigger number of students passing the exam, we have achieved something. If not,
So the assessment will happen only once in the final exam.
yes.
Do you think?
Yes.
Thank you.
Thank you. So there was something surprising and encouraging for me in the results of the survey. My experience is that students want lecturers to prepare them for the exam. And here you show that students want the lecturers to prepare them for work. Can you tell a little bit about the structure of the exam? Real-life problems, is the structure of the exam changing? Are there real-life problems on the exam?
Our exam, how is now the exam or how?
Yeah, how it's done, what the students expect, the students that participated in this, the students who participated in the survey,
Yes.
they have expectations regarding the exam.
Yes.
Perhaps they've seen exams from previous years.
No, they about they have previously how is but now we change to in the exam to put more these examples like this.
And the students who participated in the survey, they know that there is this change in the exam?
Yes.
So perhaps their expectation is to align with the exam, yeah? They understand the new expectations of the exam, and that makes sense. Thank you very much. Thanks.
Thank you. Any more questions, maybe from the online participants?
Can I ask something?
Yes.
I think that we should prepare our students, we should prepare exams in order to check their competencies that they have get during the lectures and not repeat, do not perform exams that they have the same.
There is some claim that says if you want to change learning, you must change the exam.
Exactly. So the exams should happen in following the process to check the competencies that they get.
Perhaps, yeah.
So it should not be just just one final exam. You should prepare them, through the frequent series of exams in order to check in each stages that they have the competencies based on the learning outcomes that the course is prepared, instead to have, the same topics as a final exam.
This is one aspect. The other aspect of this, I should use the microphone for people. So this is also connected to assessing the change. So if you say, I'm going to change the teaching, I'm going to change the learning, and I'm going to keep the exam the same so that I can test if my change in teaching had an effect, maybe from a research perspective, this is a good idea, but from a teaching and learning perspective, it's not so good, because if you want to change the teaching and the learning, you must also change the exam, and then you cannot use the exam to check for effectiveness because you are changing everything. You are changing the teaching method and the exam method. But it's not a problem. That's good.
Okay. If there are no other questions, thank you, Vesna. We can proceed with the next presentation by Lori Bartel. She comes from Hadassah Academic College from Israel. She will talk about a real-life example, locating a point. Lori, the next 45 minutes are yours.
Can you hear me?
Yes, we can hear you just fine.
At least I got the microphone right this time on the first try. Okay.
The presentation is showing, so everything is just fine. You can start.
Good. Thank you. Okay, so this is the third real-life example that I'm presenting here, and in fact, each one of them are different aspects of the use of these real-life examples. The first one, of the formal definition of limit, the aim was to help the students not only for motivation, but also how to grasp a difficult concept. The second one was more for eye-opening, seeing forwards what on earth they are looking at piecewise functions, and in some way make them dream a little. And this one is how to locate a point, is really how to use examples of how to use the tools that are learning in some examples that are from the field. So the subject is analytical geometry. It's a subject that teach right at the beginning of the first semester in a pre-calculus course, because it's a subject that's usually learned in high school only by students who had the highest level of mathematics and with vectors and so on. And so most of the students didn't take the subject, and the other ones, as Isim explained, they had the time to forget about it anyway, because they arrived some years after the high school. And so we start with definition of vectors, and then we explain how you can use vectors to represent a line in the plane by parametric representation of equation of the line. An equation using vectors, not equation of a line seen as a graph of a function y is mx plus b. It's not the ax plus by is equal to c. So we're going to talk at that point, going to talk about some application of this representation to computer science. And the motivation for me was, in fact, there were two things. The first, I was sometimes second-year students who were working on the project in object-oriented programming, where they have to program a game. And some of them were coming to see me in my office and ask how they can use the vectors and so on for certain problem they had in the game. And I was very surprised that even some good students who knew how to do the standard thing, getting from parametric representation to equation, looking for intersection point, distance from a point to a line, projection, all these things you find in American calculus textbooks on vectors and lines in a plane, seem to have no idea how to use it in practice, or the kind of thing they were meeting. The other motivation was that I also am directing a third-year seminar in computational geometry, which was very eye-opening for me, because it's a use of algorithm for geometry problems, and some of the little tools of mathematics, the little steps, mathematical steps that they are, were very interesting, I thought, for also the first-year students who were learning to use the vectors and so on. So I took them as an inspiration for some of the problem. So the problem, sorry, this is not what I wanted. The problem that I use is a very simplified problem, but can see afterwards that it can be part of something. So suppose that in a game you're interested in knowing if a user click, the mouse click is inside a given triangle or not. So it can be choosing some option in a game or something, or whatever. It can be, then we'll see that we're going to learn about more complex forms too. But just knowing if a given point is inside a triangle or not. So of course, and I show them, and we have a triangle. We can draw the triangle. I get a human, we'll just draw the triangle, put the point and say it's easy, it's outside. So point of view of the computer, and that's something that in computational geometry is always surprising to the students, is all the work has to do, because sometimes of things that are seemingly very easy to do, but because the computer doesn't see, then one has to think how to translate this algebraically. So the computer has 3 points and another point, and what's supposed to do with that? So start thinking about why we think why is the point outside the triangle. So if you look here, the line AC, so the point is on the wrong side of the line. And that is, in fact, what the cause for which this point is not inside the triangle. Okay, so computer point of view, fine. We can program the computer to get the equations of all the lines. Here's the point, fine, but what is the right side? How can determine the right side? So in fact, at that point, I have 2 representations of a line and a plane, and it's a good time then to talk about the differences between these 2 representations. If you look at a parametric representation, you're using direction vector and in fact, you are as on a railway track. You don't see anything neither left nor right. Okay, both sides are completely equal. You don't know what's happening on the sides. No way to differentiate between one side of the line to the other one. On the other hand, it's a great way to draw a line because you will put values of t and then you get the line. On the other hand, you have the equation, which is defined by a normal vector, AB, when the equation is given by ax plus by is equal to c. So AB is the coefficient given by the coefficients of x and y. And here we can see that, in fact, the symmetry that we had in the parametric representation is completely broken. N by points to one side of the line. So n we gives a way of differentiating between one side and the other side of the line. And so what does it mean to be on one side or the other one? So if you have a point, if you look at AP and the normal vector, on one side you get this situation, on the other side you get this situation, and then of course the difference is that here you have an acute angle and here we have an obtuse angle. It's also time to talk later about angles between vectors, that it's something that's defined between 0 and pi. And the order, because the order is the vectors is not important. So here we have an angle between 0 and pi over 2, and here from pi over 2 to pi. Okay. But computer cannot measure angles. So what do we do? So we have this new operation that we just learned about when talking about equations of lines. It's a scalar product or dot product. It's very easy to compute from a computer point of view. It's only addition and multiplication, so it's fast, it's cheap, and it's exact. If you have exact value, you get an exact value. And the dot product is linked, in fact, to the angle between the two vectors where you have we have the algebraic definition and we have a geometric interpretation, which is the length of u times the length of w times cosinus alpha. So how can we use it in our case? So the difference between an obtuse angle and acute angle is in fact a sign of cosinus. So we don't really need the value of cosinus, and we're certainly not afterwards taking the arc cosinus and looking between 0, if it's between 0 and pi over 2 or between pi over 2 and pi. So we need only the sign of the cosinus. And since the dot product is u dot w, then it's the norm of u, the length of u times the length of w is always positive. So the sign of cosinus is in fact the sign of the scalar product. So I mean, it also gives opportunity to say that when you think about the problem, you have to think about making the being lazy with computations. That is, not making unnecessary computations. So we just need to have u dot w, and an exercise, easy exercise of manipulation of scalar product and equation and so on is to check that, in fact, what does it mean that the scalar product is positive if the line is ax plus by is equal to c, then on one side you have ax plus by is greater than c, and on the other side you have ax plus by is lower than c. So in fact, here you can also think about the fact that these lines by equations, when you change the c, the constant, the value of ax plus by, you just get parallel lines, which is obvious from the definition at the beginning, but not always obvious in the mind. And this is also something that we'll see later on when we talk about level curves. So it's in fact the level curves of ax plus by, and we can differentiate the two sides, which seems to be is also obvious by intuitive um, reasoning, show that, okay, on one side will be greater, on the other side will be smaller. It cannot jump from values to values, but here you can you have the algebraic justification of this property. So computer is happier. For each line, I can check if P is on the side of the normal vector or on the opposite side. But of course, I mean, you have the normal vector, but what is the correct side? For what's the correct side or the wrong side for the triangle and the choice of normal vectors? Okay, we can see here an example that it's not always the case that outside will be on the side of the normal vector or inside. Okay? And it can be sometimes one, sometimes the other. And again, the computer doesn't see what's happening. So the answer for that is, well, we can use another point in the triangle to say what is the correct one. So for example, we have here the line AC, and 4x minus y is equal to 11. And then we have the point B, which is in a triangle. So that's the side of the triangle. You compute and you get 4x minus y is equal to 2. So that's smaller than 11. So being on the right side means being smaller than 11. And for P, we find 11.72. So it's on the other side. So this way you have a way of deciding without seeing anything what's the right side and what's the wrong side. So at that point, give exercises in the students to write a pseudocode for input the points for this problem. It can be other problems similar. These 3 points and a point P, and the output is the point P in the triangle or outside the triangle. And you have to write it, the steps to think it has to be general computation that is done by a computer, and they have to control what they do if this, then, and so on. And exactly that the correct answer is obtained without seeing anything. Okay, so once done this exercise, we can think about the same thing for other shapes. For example, the shape here on the left and the shape on the right. And on the left, everything is fine because the side, on which side of the line you are, defines exactly if you are in the polygon on the right side for the polygon or on the wrong side. So it works fine here. And here, on the other hand, we have a problem. The problem, we see that if we look at this side, then it's it divides polygon into 2 parts. In this part, the points in the polygon are on the other side than the normal vector. And in this part, the points in the polygon are on the correct side, on the same side as the normal vector. So obviously what we did before cannot be used in that case. And what's the difference between these two shapes? Well, these shapes, you have this thing that gets inside. And So we have, when we look at the side, we find that some edges are outside, on one side of the line, and some edges on the other side, and this doesn't happen here. So in fact, it's time to talk about convex shapes, and this is in fact one of the ways of defining a convex shape is that when any edge you get, so all the edges, all the other points are on the same side of the line from this edge, which is not the case here. So how we can, in fact, here in that case, how can we decide if a point is outside or inside? So the way I might have a discussion on this, and one of the most intuitive way of doing this is in fact divide the form here, the shape, into convex shapes, and decide for each of the convex, check if there is the point is inside one of these shapes, or if it's outside all the shapes, then it's outside the polygon. And then we can tell them that in fact dividing a shape into convex shapes is something that is difficult. But dividing a shape into triangles, there are algorithms for this, which I'll see if they take the seminar on computational geometry, but it's something that can be done. And then you are back to the problem of finding in a point is inside or outside a triangle. And of course, if you have many shapes, then the problem of locating a point in an efficient way needs further algorithm. But for simple maps like this, it's possible to do it just by dividing into triangles. So then you can see about related problems. If you have a lamp, for example, you have a source of light, and you have a shape, and you want to know, when you draw the drawing, which sides are lit by the source of light. So these are the three sides that are lit, and how you can find them. So in fact, you can find them exactly as we did before, because the thing what distinguishes a side that's outside, an edge that's dark, and an edge that's lit. So edge that's dark, the light is on the same side regarding this edge. It's on the same side than the polygon. Okay, it's true for this one, it's true for this one, it's true for this one. And on the other hand, for this edge that has to be lighted, the light is outside. It's on the other side of the edge with respect to the polygon. So you can, with the tools that we saw before, we can also write a pseudocode of how to say for a place where you put a light, which sides you have to have a light on, which sides keep dark. And of course, if you have complex shapes and things like this, you have to think about how to do it in an efficient way. That's also a problem that's occurs in computational geometry. And one of the uses of this problem with the light is in fact also the construction of the convex hull. So if you have points, a convex hull is the smallest convex shapes that get the point, that enclose all the points. And you can have one way of constructing it, which is an incremental construction. So you add the points one after the other, and then you adjust the convex hull. So of course, if the new point is inside the convex hull, you don't have to do anything. If it's outside, in fact, all the pieces all the edges that are lit, if we had a light here, in fact now should be erased. So you have to find which edges have to be erased, and to which what is the last vertex that connect between the dark side and the lit side, and then you connect to the point P. Same thing on the other side, and you erase the sides inside. So it's also something that you can do the steps and know exactly how to explain the computer how to do it in a simple way and not very efficient way. But in case of small number of vertices, it's completely okay. Because if you have larger number of vertices, you have to think about it. And it's also, you can do an extension to three-dimensional convex hull with the same method. So another problem that can be asked of finding a pseudocode that will do the job is there are many applications in computational geometry. You have to sort the points in a circular fashion. Also, anything that you think of how a radar looks at the world. So we have to know on a circular way which to sort the points, respecting the angles with the positive x-axis. So this point here with the red angle has a smaller angle than the point here with the green angle. So the object is the aim is sorting them, and you have the first, second, third, fourth, and so on. Now, of course, the problem I had to think then is the cosinus just doesn't differentiate between the angles above and the angles below. And if it's more than pi to 2 pi, then you don't know it from the cosinus. So if you want to write a pseudocode, you have to think how you are going to deal with that. And of course, the idea you have to think about is to divide the points between those that have a higher y than the point A that are above and the ones that are below. So those that have a smaller y. So you sort the point into two lists. You divide them into two lists, and then you sort on the decreasing cosinus, and afterwards here you sort in an increasing cosinus for the ones that are below, and this way you get the answer. Again, the thing here is you have to you need to compute the cosinus. You don't need to compute the angle. So no need of using any function like arc cosinus and so on. So the conclusion is, okay, to make the aim we want to have is to show to make the students think about the different functions of the representation of a line and how to use them. And to emphasize the importance of algebraic approach to the geometric problems using vectors, because that's the way the computer would work and can program the computer to do what they want them to do. And promote also a more algorithmic approach to geometric problems. And I must say that I had the satisfaction of having afterwards second-year students who tell me that they used what I told them in the programming of the games, that they have actually used it. So that was nice to hear. So thank you for your attention.
Thank you, Lori. It was great. I would like to move on to discussions. Please, Rodrigo.
I don't hear anything.
Hi, Laura. This is Rodrigo.
Hi.
I had up my hand because I wanted to be the first to say this has been your best talk along all the seminar. So I was expecting this because I know that this is especially interesting for you and you like to explain this with a lot of detail. I was chatting with Israel that is in front of me, thinking a new problem. So I would like to comment with all of you that suddenly we were thinking that this is a great opportunity, what you have talked, to post PBL to the students. You can take any picture of whatever you want and ask for the student, modelize the region, because you want to introduce in a computer system that selecting this region that can be the picture of the city, the region in the map or whatever. So you have to modelize all the borders and establish all the conditions for the mouse. In that moment, we are connected with your previous talk about piecewise functions.
Yes.
Bezier curves, splines, whatever you want. So, in fact, what I wanted to say is that this talk is connected with the previous talk, completely. Okay? So, it's a great opportunity because every student can choose a picture. Every student can generate the model, appear new conditions. So, you have a PBL for each student. So, the cheating can be only when the student communicate the strategy, the tools, but not exactly the solution, because every student has different solution. So my recommendation to all of you, take a copy of this talk. I will upload along the day and take home and show to your colleagues, because really it's a great fountain of inspiration for me, Israel. We were cheating along all the talks, talking about, many ideas are coming. So I wanted to express my gratitude and thanks a lot for your comment. I have no question because I will send message to you with more complicated questions, but thank you.
Thank you. Anyone else with a question? Yes, Olga, please.
Well, more a comment than a question, because I'm teaching mathematics for computer graphics and games on the 5th semester, and then later rendering animation. I mean, that is a point in or outside triangle is, how to say, daily problem that I'm teaching for more than 10 years. And you know, whatever I do, and trust me, I tried so many different approaches, it's so difficult for the students. Now I think it's difficult because you have to have exactly what you highlighted very nicely. There are those two representations of a line, and then there are two definitions of a cosine. At least for my students, that simply short circuits their brains. And how to say, if on the exam I want to prove the student that he should fail, I ask that question and it's safe failure, no problems. So, I mean, any advice how to, those double presentations of something and then two double presentations, how to, not to confuse students with that, but empower them. For me, it was so brilliant. Okay, you can connect this and that. No way, they simply don't learn.
Okay, I can also comment from my experience. When I was studying 20-something years ago, we studied analytical geometry in the first semester, and then I went through computer graphics in my probably 9th semester. And in the introductory course in the first year of studies, no one told us that geometry is actually used in gaming and graphics. So the math teachers never mentioned the practical applications. And and then I was an assistant for computer graphics and everything, and it's only later that people get to know why is it applicable. So we should shift the information for the applicability of things early on. The math teacher should never miss an opportunity to talk about the application of whatever they are teaching. So we went through analytical geometry very theoretically, not in an applicable way, which you proved is possible and useful and so on. Okay, Nisim, please. I am burning the steak from last
This is a question both to Laura and Olga. I mean, one of the things that Laura suggested is to have a computer-based exercise within the mathematics course. And then the question is if this would make them ready for your course, Olga, if they will do that. You have that.
I don't hear a thing.
She said that they do that they have a computer they have a exercise in computers within the mathematics course, and that it doesn't help in the sense that still students forget. It's 2 years later.
Yeah, my problem is that my students, when I talk about this, the students are really beginners. They are in the first month of studies. And not all of them study programming also. Some of them who are spreading the studies on 4 years choose to start programming only the second year. So I cannot ask them to do any real computer exercise, but I can ask them to think about how to give, I explain what means to a pseudocode and to give what are the instructions that they would give to decide on the answer.
Olga once again.
Again, now I want to misuse these 5 minutes to say this is exactly inspiration for that idea that I'd like to do as extra work for this project. If we somehow have that, that is a point inside triangle or not, that's cornerstone of questioning computer graphics, Laurel. You couldn't pick up a more important example. So if we make a scene in Unity where objects are made of triangles and we have a light ray, and then we are figuring out, yes, that triangle is lighted by this lamp, and then instead of just seeing that in the scene, we could see all those vectors and cosine values and everything superimposed in 3D scene in Unity, including VR goggles. Won't you like to get that in November?
I would like.
Won't you like to collaborate with that?
In physics, using diffraction theory, we can say if you give me the distance and dimension of the source, I can tell you if the triangle is illuminated or not.
Exactly. Exactly. So let's open that calculation from game engine that it becomes visible, that those becomes visible objects in game. I don't know will that work, I doubt, but at least we can try.
You should explain
Don't you think?
very well for us that we don't know mathematics, how to apply it as well.
No, it is in Unity, it is in game engine, it's already calculated, it's just hidden from the user. So what I'm proposing to do for this project is to just find some good user interface way to superimpose that mathematical both numbers and vectors over real scene that we are anyhow interested. So that while you are programming, you have that extra information.
Can I ask you something that you said before?
Yes.
You mentioned, because I did not get it, that Lauren has provided 2 definitions about the sign.
Cosine, yes.
The cosine.
Yes.
What are
One is that you multiply coordinates and sum them up, and another is to find the norm, and the rest is cosinus.
Okay, so the first one comes from the dot product?
And another comes from dot product, exactly,
So
2 different.
It's the same, I mean, it's different.
No, but
how do you express the dot product?
exactly, and that's so damn hard for the students for some reason. Is it?
For physics? No, it's straight. I mean, okay.
Check that next time with your students, please.
Checking every semester.
I had an American colleague who didn't believe me that Danish students don't know fractions. So I invited him to my class, And they said, okay, 1/5 plus 2/7. Somehow we went through that example. And then after that, I asked them, so how much is 1 over p plus 1 over q? And of course, I got the answer 2 over p plus q. And then he trusted me. So you can try that with your students also. Mine are not the worst in the world. However, I want to blame them. Thanks.
Okay. Do we have anyone else interested for a question, maybe from the online people? If there's no one else to ask.
Oh,
Yes.
I would like.
Yes, please, please.
Following what I've just heard, maybe I missed something, but so do they ever see a proof that the dot product and AB cosinus cosine of theta are equal? Or
Yes.
do they no, not our students' law. I know that our students do. I'm asking Olga, because if they just see it as coming from the Almighty, then they don't have any reason to understand it or to use it. So
Frankly, I don't know answer to your question because I'm not teaching intro mathematical courses, nor I'm teaching gymnasium mathematical courses. I can only guarantee you that when I show them those two definitions of cosine, they look pretty pale to me.
okay, so from my point of view, they should get one as a definition and the other one as a theorem, and a theorem that you prove, not you personally, excuse me. But if they just get it as something that memorize it, there's no point in memorizing, and then they're okay. We can't expect them because there are tons of things to memorize if they don't understand them. So that's the point from my point of view. And what law does, I would like, as a colleague, seeing how she works, I'm going to say a few good words. She must forgive me. But she comes as a mathematician, not as a computer scientist, and shows them, even in the first year, shows them the usage of the things that she teaches them. And then she can come again in third year when they come to the seminar and expect them and remind them. And that's the very nice thing she is doing because she doesn't expect others to do it for her. And I see how, and you see too, how many hours she invests in finding these ways and in using, she went and learned herself, of course, using all these programming tools and skills, etc. And she comes one day with the GeoGebra and the other day with something else. And that's the point. Even if the students don't know how to use these tools, she puts them on the table and she uses them and she twists functions on the on the screen, regardless of online or not online. And so the better students and those that come there to understand get the tools, and then they're on their own. And the weaker ones, yeah, we have the same problems all around the globe.
Mhm.
I think that summarizes our joint situation. Yeah. And yeah, I enjoyed the talk very much, especially after I've heard these points from her in the corridor. Yeah, we've talked more than once about locating a point in a triangle.
Thank you. Thank you very much, Iran, for the good words. And there is one thing I forgot, in fact, to tell about the importance, for example, to determine on which side, to think that you only need the scalar product, you don't need the cosinus or the angle, is the precision, and that relates to my first talk, is the precision of the results. I mean, there are many algorithms in computational geometry where it's very important to know if a point is on one side or on the other side of a segment. And if you get the wrong answer, then maybe sometimes you get problems in your algorithm. And the less computation you do, then of course, the more precise results you get. And that's also something that is a good opportunity of talking about this. As Ran said, it's a good thing to talk about this in the first year so that maybe they remember this in the third year, or there will be less surprise in the third year, say.
Okay, one more.
Thank you. So I think this is a very beautiful example, and I think it's beautiful because it generalizes what we've been thinking about as real-life problems. This is a realistic problem, something that students, and not only computer science students, can imagine, can relate to, and can see a need for some mathematics in order to address. So I think it's important that we see that real-life problems does not need to be something that I will need to solve next year in my profession. It needs to be something that I can imagine today, I can engage with, and I can see the sense in solving the problem. So thank you.
Thank you. If there are no other questions, then we wrap it up in the pre-lunch session, and we can move on with the lunch. Thank you very much. Another round of applause, please.